So, last time we started talking about forces, and we started talking about the gravitational force. Now, we learned that there were two formulas for the gravitational force. The first one was F of g is equal to your gravitational constant times your first mass times your second mass divided by the distance r between the two masses squared. Now, we discovered that this formula was predominantly for finding the gravitational force between two bodies, whether they are celestial bodies or not, to determine the attraction, the force of attraction between them. And then there was a second formula, which was the force of gravity was equal to the mass times the gravitational acceleration, where our gravitational acceleration was negative 9.81 meters per second squared. And this formula was the formula that we would typically use when we're looking at objects on the surface of a planet like the Earth or on another celestial body like the Moon. So this was the main one that we would be using for our physics class. Now today, I want to talk to you about the next force, which is called the normal force. Now, the normal force is actually a reaction force. It's a reaction against gravity. Now, this normal force requires there to be a surface. So let's say we had the ground and we had a person standing on the ground. We know that there is a gravitational pull towards the center of the Earth, but we also know that this person is not going to just sink into the Earth, right? This person is going to be actually pushed up against the Earth. And this force it's pushing up is called your normal force. It is the reaction against gravity. Now, we call it the normal force because in physics, normal is equal to perpendicular. So in this case, this normal force is actually perpendicular, forms a right angle to the surface of the Earth. So your normal force must form a right angle, so a 90-degree angle with a surface. So, in this particular case, your normal force is going to be equal to your gravitational force, but the direction is the opposite. So we always say that it's the negative of your gravitational force. So this is the first formula that we will be looking at for the normal force. Now, we're not always going to be looking at flat surfaces. Sometimes we'll be seeing a surface that's at an angle. So if we had this plane that was at an angle theta, and let's say we have this box, the gravitational force is still going to be pulling straight down on the box. However, the normal force has to be perpendicular with the surface, and the surface is at an angle. So that means that your normal force is now going to be shifted at an angle away from our gravitational force. So now, if we draw a dotted line, this is our normal force that's perpendicular with the angle, the ramp. For this case, we're going to be using this formula, where the normal force is equal to the negative of our gravitational force times the cosine of our angle. So, now that we've seen the two different situations, let's take a look at some examples. We'll do one example like this, and one example that has an angle associated with the normal force. So, let's do our first one. So, in this example, we have a table that is supporting a box. This box has a mass of 13 kilograms, and we want to know what is the normal force exerted by the table on the box. So, when we look at the formulas for the normal force, we realize that we need to know what our gravitational force is. Now, the formula for our gravitational force is our mass times our gravitational acceleration. So, the first step is to find your gravitational force. So it's going to be our mass times gravity, which in this case is 13 kilograms, times negative 9.81 meters per second squared. When you multiply this out, 13 times negative 9.81, you will get your gravitational force is negative 127.53 newtons. So, this is not our answer. This is only part of the answer. We need to find our normal force, which is the negative of our gravitational force. So, negative times negative 127.53 newtons. This will become simply positive 127.53 newtons. And it's as simple as that. Now, let's try an example where we have an angle associated. So let's say our angle is 15 degrees. We have a box that's resting on this ramp. We know that the box has a mass of 5 kilograms. We want to know what our normal force is on this box exerted by the ramp. So, just like with the last one, our first step is to find out what the gravitational force is. So, mass times gravity, so 5 kilograms times negative 9.81 meters per second squared will give us an answer of negative 49.05 newtons. Now, because this is a ramp, we need to use our formula that states that the normal force, is equal to the negative of your gravitational force times the cosine of your angle. So you plug in your gravitational force, plug in your angle, and then calculate that. And you should end up with the answer of 47.4 newtons. Thank you for paying attention. Thank you for joining me, and I will see you next time when we talk about the force of friction.